Before we start our graph characteristic chart, I need to point out a couple of things. The characteristics I'm going to put for a to the x and a to the negative x are both if a is greater than 1. If a is between 0 and 1, the characteristics are flip-flopped. So a to the x, those characteristics, if a is between 0 and 1, would match the a to the negative x. This is like earlier when I showed you in an earlier video that 2 to the negative x is the same graph as 1/2 to the positive x. All right. A to the x, which if you remember, I'm going to try to do a little sketch in here. If you remember, a to the x rode right here and crossed at 1 and went up. The domain goes left and right forever, so that's all real numbers. This one over here, a to the negative x, I want to do these at the same time, and then we'll come back and pick up the logs in a minute. A to the negative x was just reflected over the y-axis. It still goes left and right forever. Both of these, for the range, sit, unless there's a change to it, a transformation, sit above the x-axis. So that means their y values are greater than 0. You could also do this as 0 to infinity with parentheses. My x-intercept doesn't cross the x-axis unless there's a transformation, so none. My y-intercept for the generic parent function is 1. Nope, I lied. It's 0, 1. Then looking at increasing and decreasing. Well, a to the x starts low and goes upward. It's increasing from negative infinity to infinity, and decreasing none at all. A to the negative x is the other way around. It's coming downward the whole time from left to right, so it's not increasing at all, and it's decreasing from negative infinity to infinity. 1 to 1. So a quick reminder about 1 to 1 is that that would be the horizontal line test that we did for inverses. So are they 1 to 1? Yeah, they are. It's only go across once. Yes, yes. All right, asymptote. We did the log asymptote just a last video, I believe it was, but we didn't do the one for horizontal for our exponentials, okay? So for an exponential function, keep in mind that you could have a coefficient times your a to the x. You could have a transformation added or subtracted, but whatever happens, to find a horizontal asymptote for exponential functions, my brain wasn't giving me words, you would be y equals, and you replace the a to the x with a 0. So HA, y equals 0. HA, y equals 0. When we do our transformations in a later video, we'll talk about when that changes. Anything that's not the base to the power is still going to be there, and you just have that 0 in there to deal with. Continuity. Is this continuous from left to right? Yes, it is. No breaks. It doesn't have any restrictions on the domain. So, yes, it's continuous. Let's just put continuous, sorry. Continue. All right, looking at our log functions, log base a of x and len x, we're just going to do some basic graphs again. I do want to point out again that this is for a greater than 0. Crossing here at 1, we're coming up the y-axis and then shooting over towards the right. Same here. Coming up here, shooting over that way. They pretty much look the same. Okay? If my a was between 0 and 1, let's look at Desmos real quick and graph one of these for you. So if I did y equals functions, miscellaneous, log base a, y equals, let's try again, see if I can get this to work. log base A of 1/2. Oops. If you want to do a fraction, you have to put parentheses for the base. Let's start over because otherwise it's a long drawn out trying to get that to work. So the easier way to do it would just make it a 0.5 of x. So that reflects over the x-axis. So if my a is between 0 and 1 for log, instead of reflecting over the y-axis like my exponentials did, it reflects over the x-axis, which kind of follows with your thinking on inverses. So domain. Do these go forever to the left and to the right? No, they do not. They stop right here. Yes? So this is x greater than 0. Or 0 to infinity, all parentheses. Cannot equal 0. My range for these, however, does go on forever down and up. So that would be all reals, or negative infinity to infinity. These have an x-intercept at 1, 0, but no y-intercept. Increasing and decreasing. These from left to right are going up and up. So these are both increasing from negative infinity. Nope, lies. From 0 to infinity, because they don't go all the way to negative infinity. You're reading left to right. They do not decrease. If you had an a between 0 and 1, it would decrease instead of increasing. Are they 1 to 1? If I drew my horizontal lines here, yes. They both are 1 to 1. These have a vertical asymptote because, again, with the inverse thinking, whereas my exponential functions had a horizontal, which is y equals, my logs are going to have a vertical, which is x equals. And to find that, for logs, you set the argument equal to 0 and solve for x. So in this case, my VA is x equals 0. Same here. If my argument was more than just an x, then I would have to solve that. Are these continuous? So they're not continuous over all real numbers because they stop at the asymptote. So you would say they are only continuous from 0 to infinity. Okay? So we're going to jump real quick and try to cover the domain of our log functions as well before we jump into properties. If you were to graph these, it would help you a lot, and we will do that. Please notice that this is a separate function. Find the domain of each function. Domain of log functions is very heavily tied to your vertical asymptotes. There's other stuff as well, but the vertical asymptotes is going to be a pretty heavy influence. So remember I told you set your argument equal to 0. X equals 2 is my asymptote, my VA. Now, we said just a little while ago, we're going to cross at 1, right? But if I have x minus 2, that moves it. My asymptote is at x equals 2. Is this going to go to the right from there or to the left? Since my base is e, which is greater than 1, it's going to go to the right. Sorry, I meant up or down. Sorry, that's weird. All right, graph it just to double check. Y equals ln, which I have a really hard time finding for some reason, x minus 2. Moves it 2 places to the right, remember, because the x is inside, or the 2 is inside with the x. All right, let's do our others real quick. Here, if we did 2 minus x equals 0, 2 equals x again. So x equals 2 is my VA. Oh, my domain here was from 2 to infinity. Looking at 2 minus x, let's graph that and see if that's different. Back this up real quick. Boop, boop, boop. 2 minus x. Oh, that turns us around, doesn't it? That 2 minus x, because my x has a minus in front of it, changed my sign there and reflected this over the y-axis. So the ln of 2 minus x looks like my asymptote is still at 2, but my function went this way. So the domain for this one is negative infinity to 2. For the last one, x squared is my argument. X squared equals 0, x equals 0 when you take the square root. So I know that we have our normal vertical asymptote on the y-axis, but what do we graph this as? Let's look. Y equals ln of x squared. What? What in the world, you guys? So that power, that x squared, changed this a lot. So my function here is going to come up and over, up and over. So for this one, the domain is from negative infinity to infinity. Nope. Lies again, Miss Finnick. To 0. We have to break at 0 and start over because you can't equal your asymptote. All right, guys, that's graphing our log functions. We'll come back with some properties.